So welcome to your math book. We're going to start with chapter 2, equations in one variable. And in this lesson, we're going to talk about, by the end of this lesson, you should be able to say, I can solve equations using the inverse property of multiplication. I can solve equations with rational coefficients. And just a reminder, rational are those kinds of numbers that you can write as a fraction. So we're going to deal with fractions and decimals in our equations today. So the vocab that you're responsible for in this section would be multiplicative inverse and coefficient. Those, if we turn to page 108 in your book, page 108, you'll find the list of vocabulary for this entire unit. As we go for each section, I will revisit this list and I will add the page numbers for each vocabulary term that you're responsible for. That way you have a list of where to go when you need to know those what those words mean besides just the glossary. Also, so that you're aware, every one of these slides pretty much will have a thumbnail version of the full page that you're going to look at or be on with me. I'm going to just concentrate on part of the page, but you'll have the thumbnail version to see, and the page number will be at the top right as well. So turning to page 111, our first vocabulary term comes up, and that is multiplicative inverses. Multiplicative inverses, besides just being a fun word to say, means the numbers with a product of 1. So two numbers with a product of 1. So when we multiply, because product means times, when we multiply 3/4 times 4/3, we get 1. Those are multiplicative inverses, also known as reciprocals, when you flip a fraction. So that's your first vocabulary term, and we're going to use those a lot this section. Turning to page 112 at the top, they tell us the inverse property of multiplication, what that is. We already kind of know what it is because we know what multiplicative inverses are now. But the product of a number and its multiplicative inverse is 1. So that's always going to be true. And we're going to use that property by the end of this. You should be able to say, I can use the inverse properties of multiplication to solve equations. Our second vocabulary term is underneath that. Coefficient is in yellow. They give you a complicated version of the definition, a numerical factor of a term that contains a variable. But really what you need to know is it's a number times a variable. And yes, you should write this down right in your book. And so they give you the example, 3x, x being the variable, 3 being the number multiplied by the x, so that is your coefficient. Then down here in the equation, we have 3/4 c equals 18. C is the variable, 3/4 is the coefficient. Before we solve that, we're going to talk a little bit about the 3 main guiding principles that you need to understand to solve any equation ever. So, solving equations, guiding principles. 1. Very first thing you need to know. The goal of solving an equation is to isolate the variable. Every single thing you do to solve an equation is about getting that variable by itself. Whatever you do to one side of the equation, you have to do to the other. Okay, so those are our properties of equality. You can add, subtract, multiply, or divide anything you want to an equation as long as you do the same thing to both sides. And to solve an equation, you're going to undo it. So when you're stuck with how do you get the variable by itself, look at what it's asking you to do and work backwards. Do the opposite of what it says. So taking a look at page 112, again, in the example number 1, they show you how to solve that equation we just talked about, 3/4 c equals 18. This is all the work. And over here is the explanation for it. Underneath, they show you the work for how to check your answer and the explanation. You need to look at these things as your notes when you're confused about how to do something. All of the information is right there for you written out. So let's take a look at the got it questions. We're going to do letter D together. I'm going to rewrite mine over here. You can rewrite yours wherever you want, that you have space. They give you some space over in the side to work over here, but I don't have enough room there, so I'm going to work over here. So we need P by itself. The goal of solving an equation is to get the variable by itself, so we need to get rid of times -6/7. In order to undo times, ordinarily we would divide by -6/7. But whenever you divide by a fraction, you have to multiply by the reciprocal or the multiplicative inverse. So we're just going to skip the divide part and go right to the multiply by the reciprocal part. So we're going to multiply both sides of this equation by negative 7/6. We're going to flip our fraction. So our 6/7 becomes 7/6, and we want to make sure we keep it negative. On this side, if I do that to one side of the equation, the right side of the equal sign, I have to do the same thing to the left side of the equal sign. So on the left, I'm going to multiply the negative 24 by negative 7/6. I wrote the 24 over 1 because it oftentimes makes the math easier. It makes it easier to make sure that the numbers are in the right spot. You don't have to do that, though. So taking a look at the left side to figure out what this answer is going to be, I noticed that 6 and 24 both have common factors, so I'm going to use that. 6 goes into 6 one time. And 6 goes into 24 4 times. Now my math will be a lot easier. I have 1's in the denominator, so when I multiply, my fraction will disappear. So I have negative 7 times negative 4, and so I get 28 equals, on this right side of the equation, I have negative 6/7 times negative 7/6. We know those are multiplicative inverses, so they're going to equal 1. So I'm left with P, or 1P if you prefer, equals 28. The variable is by itself. That's how I know I'm done. So let's take a look at a few more examples if we have time. So on page 113, taking a look at page 113, again, here's an example done out for you. Here's the explanation. Now we're going to do one together. So let's take a look at letter F. Okay, so letter F says 1 7/8, and yes, you need to do these problems with me. 1 7/8 y equals 4 1/2. So the first step when we're dealing with multiplying and dividing fractions has always been to make the mixed numbers into improper fractions. It's no different with equations. So I'm going to multiply and add to make these mixed numbers into improper fractions. So 7 times 1 is 8, 8 times 1 is 8 plus 7 is 15 eighths y, and 2 times 4 is 8 plus 1 is 9 halves. So now we want y by itself. Everything we do is about getting y by itself, and so we need to get rid of times 15 eighths. What we're going to do is multiply by the multiplicative inverse, or the reciprocal. And if I do that to one side, I have to do the same thing to the other. And so I'm going to do that to the left side of the equation as well. So I notice here that instead of multiplying 8 times 8, well, actually I have 8/15 times 15 eighths. These are multiplicative inverses, and so those are going to be gone. I'm left with y, or 1y, because the product of the inverses is equal to 1. And then over here I'm noticing that I can cancel out some of my numbers as well. I can cross cancel. So 2 goes into 2 one time, and 2 goes into 8 4 times. And 3 goes into 9 3 times, and into 15 5 times. So now I have 3 times 4 is 12. 1 times 5 is 5, so I have 12 fifths as my answer, which you can leave this way, but it's probably better because you started with mixed numbers in your original problem to make it into a mixed number. So we have 5 goes into 12 2 times with 2 left over. So 2 and 2 fifths is my final answer. Y equals 2 and 2 fifths. Moving along. So taking a look at page 113, what happens when we have decimals for coefficients? Well, it means we're going to have to deal with decimals for coefficients, that's all. We're just going to have to do a little decimal division. So taking a look at the example they give you how to do it, they give you exactly what the work is, they give you the explanation, they show you the check and the work for that, and they give you the explanation. So let's try one of these. Let's try letter H. So we have negative 1 4/10 m equals 2 1/10. We need to get the variable by itself, so we need to get rid of times negative 1.4. So we're going to divide by negative 1.4. If I do that to the left side of the equal sign, I need to do the same exact thing to the right side of the equal sign. So when I do that, the 1 and 4/10 cancel each other out. I'm left with m equals whatever 2 and 1/10 divided by 1.4 equals. So over here, I'm going to do my decimal division. Hopefully you'll notice a few similarities here with the 2 and 1/10, the 21 and the 14. Hopefully you'll notice common factors and things like that. So I can't divide by the decimal. I'm going to move the decimal point to the end. So I need to do, and that's one place to the right, so I'm going to need to move the other decimal point one place to the right as well. So now I'm really dividing, figuring out how many times 14 goes into 21. So 14 does not go into 2. I'm going to put the 0 here to make sure that I don't write a number there. 14 goes into 21 one time. 1 times 14 is 14. Subtract. I get 7. And now I am out of numbers, so I'm going to have my decimal point here. I'm going to add a 0, drop a 0. Now I need to know how many times 14 goes into 70. 14 goes into 70, I believe, 5 times. I'm not sure though, so I'm going to come over here and do a little multiplication to see. 4 times 5 is 20. 5 times 1 plus 2 is 70. So I'm correct. It goes in 5 times. Multiply. 14 times 5 is 70. We already knew that. Subtract. I get 0 as my answer. So 1.5 is what I get. Now I have positive 21 divided by a negative. So my answer is going to be negative 1.5. So 14 goes into 21 basically 1.5 times. And that is my final answer. Taking a look at a word problem here. So just a quick review. To write a percent as a decimal, we move the decimal point 2 places to the left. So to change 75% to the decimal, what they did was change it to 0.75. So 75%, when you don't see the decimal point, it's always to the right. Moved it 2 places to get 0.75. So 75% of its games. So Latoya's softball team won 75% or 18 of its games. Define a variable. So what's the variable is what they're looking for, and what does it stand for? Then write and solve an equation to determine the number of games the team played. So they won 18 games, and that was 75% played. So N is going to represent the number of games played. Write and solve an equation. So N is the total number of games played. They won 75% of those. And so of means times. So 0.75 times the number of games is the same as 18 is what this equation is saying. And so when you solve that, you divide by both sides by 75 hundredths or 0.75. And you find that they played 24 games. So they won 18 out of their 24 games. So, I know that was fast, but for homework, you're going to try page 115, numbers 1 through 12 long. Okay, that is your homework, that's your practice for this section. Have fun.